So, good afternoon once again, everyone, and welcome to the session 10. Sorry, not session 10, we are on the session 12 now. So, we are on the last day, session 12. And for this session, we have Mr. Tarang Aggarwal from Qualcomm with us. So, before we start, let me give you a very brief intro. Mr. Tarang Aggarwal completed his MTech from IIT BHU, Varanasi, and he has professional experience working with IBM, ARM, and Qualcomm, where he has been a part of CPU verification teams for both IBM and ARM related architectures. Currently, he is working with Qualcomm. So, with this brief intro, I welcome Mr. Tarang Aggarwal, and now I hand over the session to you, sir. Please share your screen and please go ahead.
Sure. Yeah, thanks, Pankaj. Let me just share. And, oops. Okay, let me just share the screen itself. Yeah, just let me know once you are able to see my screen.
Okay. Yeah, we can see your screen. Just put it in full screen mode and then you'll be good to go.
Yeah, just 1 second. My laptop is. Where is screen? Yeah. Okay, good afternoon, everyone. Thanks for giving me the opportunity to give my experience and share my experience with all of you. Whatever I have done in this industry, VLSI industry, for past 13 and 14 years. So I thought I don't have much of the PPT presented updated here, so I'll just share whatever is useful to all of you, which you people, I know that for a lot of you, you are going to pursue your career after finishing your academics from NIT Kurukshetra. So I would, give some insights, what could be useful for you and how you should see it in your future with respect to that. So I think Pankaj has already given a brief introduction about myself. So I did my master's from BHU, and after that, I'm a part of this VLSI industry where I have worked on multiple projects, CPU, generations of CPU in IBM, ARM, and Qualcomm, where a complex core is always designed, and we do the verification of that part. So I have been a part of that journey. So before going to that and giving more into that, what will be going ahead in your career, what could be useful for you people to prepare when you go and pursue these opportunities. I just thought, because we know that artificial intelligence is a very uh, hot topic right now and a big breakthrough in all of which we have noticed in our generation. So I thought, why not use this opportunity and platform to give a understand how all the VLSI started and how we are to a level of artificial intelligence today. So I'll just start with that, an evaluation of electronics, how it all happened. So we all know that our first, I think in all our academics, we would have studied that it all started with the vacuum tubes, which was the first application and invention which were used in electronic computers, and massive product was designed through vacuum tubes. And for a very small applications, like even for a small calculation, a complex calculation, vacuum tubes were used and was massive in size. And you can imagine that for a small application, the product was in the size of a room. That was the complexity and the product space it was consuming, and a lot of power it was consuming. But that was a breakthrough at that time, from where the electronics and VLSI era started. And then from there, the transistor era came, where this big vacuum tubes were converted to a very small transistor era, through which it was a very I mean, I, I think someone is not on mute, so voice is echoing. So I would request if you can go on mute.
I'll take care of that. Don't worry.
So yeah. So from these bulky vacuum tubes, we this transistor was designed, which made us to go into much more complex problem solvings, and through which we were able to go into the telephonic industries. Computers were able to solve much more complex problems. It was also introduced on World War II for military equipments, and even the first hearing aids in America was also during this era using this transistor. So that was a very big through in VLSI in electronics industry. And of course, after that, the integrated circuit revolution came, where all these transistors we combined, and all these components where we were able to fabricate on a single chip, and we were able to use it for much more uh, many more applications, microprocessors. And first Intel computer was also invented during 1960s and 1970s, when ICs were introduced, even for army operations. And the uses became very complex and advanced. Even guiding systems, satellites, all those were part of this the integrated circuit revolutions. Once we go ahead and went from vacuum tubes to transistors, and then we were able to fabricate all those transistors onto a single chip along with many other components. So that's how the revolution happened. Then microprocessor and personal computer era came. So far, whatever applications we saw, it was all for the very high end purposes, for a very government use purposes, elite uses, and specific for a very specific, I can say, uses. But now through this microprocessor and personal computer era, it reached to each and every person's house. This is the era where the computers were invented, and we were able to do word processing first time, text processing, spreadsheet analysis was done using the computers. And then internet also was introduced, and communication was happening. Internet and communication was happening. You can imagine that uh, in this era, basically whatever we saw before, it was for many high end applications on a government level, military application levels. But this is an era where it ended and reached to an end customer. Even a public platform we were able to reach, because the applications were so much useful for them. So this is the era where microprocessors and personal computers were introduced. Then of course digital revolution came. I think most of us would be in that era where we saw that digital revolution happen. The personal computers, world wide web happened, where thousands of applications we were able to use. We were able to access data across the globe from any place. In any place you can sit on your computer using world wide web and access the information and data. And a lot of communication and socio-economic changes happened during this time because of this revolution. Because the globe was no more alien to, one continent was no more alien to other continent, because of the world wide web. We have this www uses in internet came. And then wi-fi router was also introduced, where you need not to just sit on a computer and use the a wired system to access the data anywhere. It was introduced slowly into your phones also. All those things happened. And then lately mobile and cloud computing. Mobile, we all know that how much the breakthrough happened through it, from an analog digital, that button pad of blueberry, very high end phones. Then Apple introduced the touch pads, completely a revolution for at that time. And Steve Jobs definitely gave a, broadcasted it, and it became a very big thing. That so far the blueberry phone used to be the very high end phone and a very elite phone, but the buttons and keypads used to be like an analog what we have in our laptops. And then the first time Apple came with a digital phone, where when your buttons are not in use, it will just become a display and a touchpad for you. So all those mobile and the next thing came as a cloud through which you used to have your hard disk. Your data used to be always be in a physical form for you. And then with the internet, the servers, big stacks of data, the cloud computing got introduced. And I think all of us today leverage and use that profoundly completely in our daily uses. You want to go for an interview, you want to, on an airport, you want to have all your documents and everything is on cloud. You just need to open an application, for example DigiYatra, let me say, or any application on the Google Clouds. All your data is present there, from photos, videos, and everything. You need not to have and carry that in physical form everywhere. You just need to log into your ID, have an internet connection, and get all your data through this cloud computing era. This is a major breakthrough which made us, all of us, to it also opened a lot of, I could say, employment. So the cloud is the one thing after which we see that YouTube, Instagram, and all those things started coming, and people started, it's a livelihood for millions of people today. How? Through cloud computing. The data someone uploads, and thousands and millions of people watch it, live it through the cloud computing and the server systems. So this is how the revolution happened of the electronics and VLSI industry, from a big vacuum tube to a place where in your small mobile phone you can access, uh, like a data which is unimaginable for anyone. Like we cannot even imagine in the application. I think today's words, we cannot imagine our life without of these uses. It is everywhere for all of our problems. We have the solution on clouds and through our mobile. For everyone, the technology, we interact with it on the daily basis, lives, cameras, everything. I mean to say, whatever application you say, it is through mobile and computing and cloud computing today. Now coming to the latest topic, I think this is what we all know: artificial intelligence, AI, which is like a breakthrough for all of us. Again, it is what. See, what we need to understand here is, whatever I have shown you all so far, it is not an idea or a new invention. Never happens from zero. It always happens for with the motivation and inspiration from the behind the technology. So if you see, if we connect the dot of current AI and artificial intelligence, we know that all the previous slides put an important role and have an important role for us to reach here. We cannot imagine AI today without having a cloud. We cannot imagine a cloud without having an invention on the mobile phone. We cannot imagine a mobile phone without having an IC or a transistor or anything. So the fundamental and the foundation was a very small thing, and through which today we are in the artificial intelligence era. And just imagine that today on a computer you are sitting, you have any complex problem, you can have a project, mathematical problem. You need not to have a third person, or you need not to wait for to have a physical human being for you to solve that problem or answer you for that. There is an AI through which you just need to type your problem, and they will help you guide by guide, step by step. You want to generate a web application, there is an AI through which it will help you step by step. You need to create a logo for your company, you want to make a cover of your book, anything you want to do, AI is there. AI is present there. How it is doing? It is doing by using our applications, using our experiences. So this is how the AI works, that million of users use it on the daily basis, put their problems, and make it more smart day by day. When AI, just imagine, like a some time back, I still remember, like if I'm not wrong, around 2.5 year back, a very simple AI web application was introduced. What it used to do is, you draw any shape, any fruit or anything, you just draw it with your imagination, and it used to produce the name for it. And if it doesn't produce the right name, it will ask you either to give the right name or reshape it. That was the thing which happened 2.5 year back. And through where, because the applications and the users are in millions, it has reached to a level where it is now able to solve the most complex problem in VLSI industry. A lot of us are using now for our RTL coding, for our checkers writing, for verification methodology. We are using completely AI tools to help us, be it writing a small code or writing a complex code, finding the assertions, coverage points, everything. So, I mean, even us, we as a semiconductor industry is also not untouched by AI uses now. So through this presentation, I would urge all of you to, if you have not adopted this latest technology, I would request all of you and urge you that go ahead, pick some daily examples wherever you feel that you are stuck, either in your academics or whatever you want to achieve, and you feel that there is no one who is here for me to help, or I need a guidance on that. Use an AI tool, and I'm definitely very sure that it will definitely help you in one way or other way for any application. So this is what my experience has been so far. So I thought I'll share with you. Now, coming to a bit of this industry and what I have worked, I have worked so far in this. I have been a part of functional verification of a of you can say, or any small microprocessor. The verification part, if I have to give you a small brief, is a common part for any logic you want to develop in terms of electronics or semiconductors, if I have to say. So like software people, if they are there, we know that there are two major components there. One is the development, second is the testing. Similarly, in verification, if we have to drive them into two similar concepts of software, it will be design and verification. So with design is what exactly you want to design or write a model or create a logic or an application for which you write a design code. You design that piece of logic. And verification is the part where we make sure that functionally whatever this code or this logic is intended to do, it is doing that. So when we say verification, there are many things, other things are there, but this verification process is before the fabrication. So that is a major difference in when it comes to software and hardware. That software, your code is completely in the soft format in the applications. But when it comes to hardware, your code and your things get fabricated onto a physical chip. So for that, we use hardware language, which is VHDL, System Verilog, Verilog, through which we do the RTL coding and everything, and then later it gets fabricated internally. Slowly in the process, go deep down to the a very small, you can say, transistors and ICs only in that format. But before doing that, we have to make sure that there is no bugs, no design issues. The functionality is doing absolutely correct, whatever it is intended to do, and that is what the verification process is. Again, in verification also there are multiple things, but the two major fields are functional verification and formal verification. I am a part of functional verification team, which makes sure, as I say, with writing a lot of stimulus, we drive the like just again to give a brief about that a logic will have generally, you will provide an input to that, and then with those inputs it is intended to produce some outputs. So what we as a verification engineers need to make sure is that we cover each and every corner cases of those inputs, so that in the real applications, or when the chip gets fabricated, the whatever the real inputs it can be generated onto the real application, we have to generate each and every corner case before the chip gets fabricated on the simulation time, and then it produces whatever the output it is supposed to produce. We need to make sure that the outputs are as expected. So the major parts of this to cover is stimulus generation. You make sure that all the inputs are generated, there are no cases which you missed. Then whatever the outputs, the logic is generated, this is well checked. You are making sure that functionality is doing as expected, and then this is the basic idea I have to give. But to have this thing to functionally verify it for a very small thing, let's say if, for example, if you are writing on your academics a 4-bit adder. So 4-bit adder, for you it might seem very simple. Oh, it's just a 4-bit adder, I need to make sure I randomize all the 4 bits, and then whatever the output is produced, I make sure that all the outputs are produced, whatever the values are, and the carry bits is also produced correctly. But when it comes to computers, we have a course, single core, which is now in the pipelining architecture. In that pipelining architecture, there could be multiple faults, exceptions, like memory management unit comes. I hope some of you would have be a part of computer architecture also. And then again comes that with this core, we are now generating multi-core systems. So again, a single core might be for a very simple applications might be used, but when it comes to servers, imagine we are dealing with billions and trillions of data. So for that, the server stack gets created in which there might be some, you can imagine like 48 cores on one cluster, and then multiple clusters in a stack in a server completely, and then they are interacting with each other. So it adds to a complexity of another level. So all those things we need to verify, and we have to make sure that whatever it is intended to do, it is not breaking in power terms, in clock ratio terms, not functionally, it is not breaking, it is not producing a wrong result for you. So all those things, we as a verification engineer from a VLSI engineer make sure that it happens. Um, so yeah, that's a basic idea. I hope it would have helped people, all of you, to understand in a bit of terms. So now, I know, I hope some of the students will also be present in this conference. So if you are willing to pursue or looking after your academics to go and pursue your career into the VLSI, these are the couple of things which I mentioned here. Pipelining architecture, which is a very important topic. You have to know now caches, know a bit of cache concepts, different protocols. I know in academics it might be difficult to do the hands-on, or I'm not sure. I'm not so much updated about how much is the in the academics, what kind of experiments and in lab experiments happen. But if you have a touch of a bit of some of your serial protocols, or like a AXI protocol or some basic protocols, if you have a knowledge about that, it will definitely help for you to understand how the communication happens from one core to any other chip which is sitting outside the core, or a core to core within a core itself. What is the role of caches, how a pipelining architecture works. And then Python is not exactly, I could say, a language which is, you can say, a direct use in VLSI industry. But what it now, Python is a very major, plays a major role of helping you uh, do things in automatic way, in automation. So anything you do, Python will be useful in any industry. So this is one language which I think everyone should have a hands on if you are from this industry. Then, as I gave the example of multi-core systems, power and clock ratio scenarios. Power, as we know, power is a very important thing which play a role even in electronics also. I think a lot of you people must have used so far a lot of computers and laptops, and you would have felt that if we use certain heavy applications or applications, for a computer laptop for a very huge time, you must feel that okay, there is a heat which is happening in the laptop. So these are the things which we also need to make sure when we are developing a new code, because we know that kind of applications now people run on their laptops and mobile phones and everything. People play a very heavy games also. So all those things also come into picture. Performance, power. That when you are opening a lot of heavy websites, your phone should not get stuck. Your laptop should not get stuck. It should not get heated. It should not automatically go into a switch on mode or switch off mode. And then clock ratio. I think all of you must be knowing it a little bit, that in your academics, that clock ratio is nothing but like if the lot of things on a single chip, a lot of IP components interact with each other. Like core will be interacting with some other components which will be sitting, and then they will be interacting with the main memory. Then there will be a LLC, last level cache, all those things. But the thing is, they can run onto the different clocks. One thing could be faster and another thing could be smaller. Again, like as I say, that it's an integrated circuit now. Everything need not to be on the same clocks. Everything need not to run similarly. Everything need not to be designed on the same time. So what we do is we integrate all of these different IPs onto a single chip. Now, someone might have designed an application on a bit on a faster clock, while your core might be running on a smaller, a little bit of slower clock, or maybe your master is running on a faster clock, and slave is not that much of a faster. So what we need to make sure is we need to also drive those scenarios that if something is very fast, our system should not break or should not crash. So all those things come into the clock ratio scenarios where we make sure that the synchronizers are present in between to make sure that if any faster transistor or master is there, um, until and unless slave is free or it has finished all the previous operations, the further transactions are not provided to it. So through this, we are able to make sure that multiple work can be done on the different levels, but they still can be integrated together on a single chip through these clock synchronizers, where even if an application is a little faster or a slower than the other one, we still can integrate them together and make it work. We need not to have that kind of thing. Oh, I think this particular component is a bit slow, so how I cannot design an IP through this, I cannot design an integrated circuit through this will not work. So through which this synchronizer will help in that way. Okay, so yeah, so that's what this was. And then, as I mentioned, please use AI as much as possible for your daily works in any form, whatever you want to do. Just try to use it in some or other way application. And so just to say that, I think invention has always been an important part in any field, not only in VLSI, in every field, be it mechanical, electronics, electrical, in every field, invention has always been happened. But it doesn't mean that if someone is not a part of that invention or is not, uh, not able to figure out that, oh, uh, I mean to say that invention should not is not needed to be a part of everyone's plate. The most important thing is we also need to be relevant with the times. So i- invention has happened, it will keep happening. Some people will be a part of that invention, some people will be a users of that application or inventions. But there might be cases where people don't want to, people are still relevant even if you are not part of the latest inventions. So just to give an analogy, just imagine that we are running into the digital era where everything is now digitalized, from everything what we can think about, but still we have the top royal brands of watches which are in analog form. So if you say Rolex, or we have some other brands which are still running analog watches, and it is the costliest watches we can imagine, and people use it and they are still relevant. Even in this digital era, there are smart watches which are coming, people are using it. Most of the applications, most of the users are from the digital watch era. But what I'm trying to say here is that relevance is important. You relevant Being relevant is as important as being a part of the invention, the latest trend, what is happening. So for that, I just wanted to give you an example of the watches where analog watches are still there. But even being relevant and being competitive in as opposed to whatever is happening latest in the industry, you also need to be updated. So we had used to have a very big Indian brand which is used to be HMT. I know all of you and most of you must have heard from your grandfather's times that, oh, they used to have a watch which used to be HMT, which was a very elite watch and a very powerful watch at that time, but it couldn't pick the market. It couldn't go to the latest trend. Even if it was an analog watch, even we have the analog watches today, but that it couldn't pick up the market. It couldn't run with the latest trends, whatever it could be. Might be it didn't. Might be it was not in. They didn't want to be in that era of digitals, but they could have picked something into the era of whatever the latest technology is happening in mechanical or in any other format, which could have made them stand out in the watch industry. So being relevant is important, but being updated and being knowing where to update and what to update is also as important with the time. Similarly, in our industry, we know that Nokia phone was one thing, and as I gave the example of BlueBerry. So I think if you people go back, there is a very nice video of Steve Jobs. At that time, he has used that BlueBerry phone as an example when the breakthrough happened, where before Apple introduces this touchpad iPhones, BlueBerry used to be a high end, very high custom end phone, very costly phone at that point. the feature was very attractive, the keypads were very attractive, the display was nice as compared to other phones, but they didn't survive after that because they didn't pick the latest trend. They didn't think about the future, and they didn't think about out of the box. And that's what Apple came up with, the touchpad, where all the data, all the space was, which is only was previously meant for typing and hard coded keypads. He introduced the touchpad buttons, where when you are not using those key buttons, it will automatically become a complete display for you. So that is another thing. Similarly, Nokia, we all know that Nokia also lost because they couldn't go with the trend. So that is why today's time is, the today's era is artificial intelligence. You it is like uh, as soon as you become a user of that, you will also be ahead in your time in whatever you want to do ahead. So I would suggest and I would request all of you to go ahead. If you are not using artificial intelligence right now, please go ahead and start using it. Yeah. Yeah, that's all from my side. Um, Anyone has any questions for me? What happened? Hello.
Thank you, Tarang. Anyone from
Thank
the
you.
audience want to ask any question?
Sir,
Okay,
I have
Tarang,
one question, sir.
one query from my side. You just discussed
Yeah.
about the Python here. I just wanted
Yes.
to ask,
Yes.
is there any interface where we can integrate this Python with the hardware, some hardware language like Verilog or something like that, where we can means implement our this software framework on the hardware platform? Is there any language or that is being used in the industry, something like that?
No, so hardware languages. So no, for with system Verilog or Verilog or with the VHDL, we cannot integrate any software language, because as I say, this get converted into the transistor list kind of thing, and then it gets fabricated. But all these languages, whether it's CPP or Python or any of these things, are majorly used for us in the verification or to automate the process. So as I say, that it's just not writing a file, it is not just coding a file into VHDL or system Verilog. We need to have multiple other things. We have to have the steps of, um, like simple example, that maybe thousands of VHDL files or Verilog files are being created, but uh, the format of all of them might be same, and then people want to just code them directly. They don't want to manually write the format. Like for example, if you open a PPT, what will happen is you write the first slide, and what you expect is whatever the layout I have chosen for the first slide, automatically it gets gone to the next one on the same thing. Now, what you want to write on that PPT, it is up to you. But you want the layout not to be done manually. So Python or anything automation works for us in that way, that it help us doing that work very easily. Be it in automation regression or creating a framework or creating a layout for us. All these languages, all these automation work happen using these languages in hardware in the VLSI. CPP we use again checkers, as I mentioned. VHDL is a part which we fabricate and create a chip out of that, but still we are doing everything onto the software side. So CPP helps us to write the functional coding and create everything functionally, whatever we want to verify in the CPP file, because they are much easier to handle and easier to work on. It's very C++ has always been very easy for anyone to learn as compared to any other language. So that's how it helps us to verify our functionality for that RTL code.
Okay, Tarang, there is one more question from Raj Lakshmi. Uh,
Okay, please go ahead.
the question is how AI can be used in academics. I think it should be related to VLSI specifically, because question is very general that how AI can be used in academics.
Anything, I think that is what my first point here was. Until and unless you have opened an AI application, AI web page, you don't know how much it is useful now. I can tell you an example. I can tell you multiple examples for you as an academic. Let's say, as I gave an example, or for example, if you are in a final year of your project and you want to write a coder, you want to write a 4-bit adder. Now, what you need to do is you have written it and you want to cross verify it. Just type a simple line into an AI application tool. I create a system Verilog 4-bit adder for me, and will completely write a code for you. You want to have a simple application, simple mathematical problem, just go and type it there. It will provide a complete solution for you. So let's say in your academics, if you are reading multiple projects, multiple subjects, try to use it for any problem where you are stuck. It could be a simple academic problem also, it could be a core issue, it could be a communication, any subject. Just type it and you will understand that how much it is useful. I mean, it is so much, honestly speaking, it is so much addictive that I think slowly you people will be using much more time, spending more time on AI applications rather than in any other applications, on any other apps or any other things, because it is so useful. So as I gave the example, you want to create like you want to, someone might to, for example, write a book, and they are not able to understand that what should be the cover of my book. So you will just type, this is my title of my book, and please create a cover page for this title. AI will provide you. It might not be very smart, but that's how they are learning, and you need to give more feedback on that. So might be they first time give you a very basic layout, and then you say, okay, please improve it in this way, I want this background color, or I want something in on the right side or something in that, and they again will improve and give you a better cover book. So this is how it is, not only for VLSI, it is not only for a specific application, it is for anywhere. I know many IIT students who are doing some diploma courses, and they have the exams, whatever problems they face, they are not just relying on anything. They just type their problem in AI, and AI gives them the solution and provide the proper solution. Okay, this is the problem, and this is where this is how the solution will happen. So start using it. When you will use it, then you will understand that it is not specific to only one problem or one particular subject. It is for across all the things.
Okay, there is one more from Kirti Singh. What are the some emerging trends in semiconductor and AI era for Python language?
No, Python languages, as I say, has it has no direct dependency on semiconductor era or AI or anything. Python language has become a very prominent part of VLSI, not only VLSI, on any application base or anything where the coding will be involved. So there is you can imagine that it will always go in hand. More and more complex logics and more complex programming we will do, we will always be in a need of these automation languages, which will help us to do that work faster, more efficient, and more effective.
Okay, I think this is all from our side. Thank you, Tarang, for this such a wonderful session. I hope you must have also enjoyed means sharing your experience with the participants as well as with us. So,
Sure.
participants, we will be soon be joining with the next session. It is around 5 p.m. So, thank you very much for joining. Thank you, Tarang. Thank you once again.
Thank you, everyone. Thank you, everyone.
Okay.
Thanks.
Okay.
Okay, bye.